Hello and welcome to the Engine Performance Expo, hosted by Joe Castello and joined by myself, Lake Speed Jr., and Andy Rottler. This was a live internet event from January 7th, 8th, and 9th of 2021. We did this event because there wasn't any trade shows this year, but we wanted to make sure that the engine performance industry still had a resource to tap in to the latest technical information for this year. The great news is, not only do we have a live event attended by thousands of engine builders from all around the world, we recorded this event and now it's available for you to watch today. As I said, this event was recorded live, but it also featured pre-recorded segments from top engine builders all across the country that played during the event. Then the audience could participate in live question and answer with those engine builders during the event. Over the course of the next several months, we will be releasing each week edited segments of the tech information along with the related question and answer session. That way, it's just like being there live, except you get to watch it on your time. I hope you enjoy. Sit back and enjoy the Engine Performance Expo.
Everybody to watch and actually build an engine, which is going to be fantastic. You've got to take great pride in your backing of this.
Yes, it's been a challenge, but as Lake said, we adapt to the new issues that approach us one way or the other, and it's been amazing how our crew, you and everybody that's involved in this program has come together in such a short time to put together what we think is a very valuable program for everybody, and actually dispersing it amongst a greater quantity of people than we would if we were on an actual show site. So the virtual system is very exciting to get started on.
And what's great is that if you're watching right now, you can invite your friends, you can post a link on social media, and we're going to be going for 3 days. We've got incredible guests, Lake.
Oh, yes, we do.
You're going to want to see this, and of course it's going to live forever on the internet.
And that's the best part, is that what we're doing isn't just the here and now. And that's one thing about a trade show, is that it's great while you're there, but then it's gone. It's effervescent.
Yeah.
This stays, that you can come back and watch it day after day, a week from now, a year from now. This is still here, so it becomes a living entity, which is something that's revolutionary in a big way.
Yes, yeah. You can see a demonstration at a show. Sometimes the shows are so busy that it's difficult to get an opportunity to see a demonstration. There's an unlimited number of people that can watch the demonstration today as we're doing it live, or like you say, anytime in the future.
And share it, and you won't have to sort through that giant pile of business cards after the end. Like, who was that guy? Did I meet that guy? Did I find that one? But we are going to have a lot of contacts at the end of this.
Oh yeah, and one of the neat things that we're just talking about that lives on, and the ability to process that information at a slower rate. I remember AETC that used to happen before the show, the PRI show. It was 3 days a deal as well, and it was all these great speakers, very similar to this format. But your brain was fried at the end of every day because there's so much information, which your brain will be fried if you watch all 3 days of this too, which is great. The nice thing is, this, you can come back.
Yeah.
If you miss something, you can rewind it and watch it again. That's what's really neat about this format, is it's something completely different than we've ever had before, which I think is going to empower people to take on that challenge. You can build more power, more durability, and we're going to show you how over the next 3 days. And it's not just us doing it. It's Warren, the Professor Johnson. It's Ed Peak. It's John Kazi. It's John Callies here live on the set. That's what's going to be amazing. It's the best of the best giving us the direction in the future.
Absolutely.
Yes.
And the idea that we've been able to bring together this group of just the best intellects and some of the innovators in motorsport of all kinds, they come, they're going to be here either virtually or actually in person, which is going to be amazing with Warren Johnson. We're going to be able to bounce ideas, ask questions in real time. The audience out there is going to be able to participate by asking questions. So I just think that we all want to be together, and we all are together.
Yes.
We're just kind of doing it in a different way.
Yeah.
So one of the cool things about this format that you were just talking about, Joe, is that we're going to begin today with an engine block. You know, the heart, the backbone of the engine, if you will, the block. And then by Saturday afternoon, we're going to have an engine running on the dyno. Now, there's not a dyno here, but I mean, the thing is, we're going to move that progression from taking a block in the initial machining, lifter bushings, honing, and then run it all the way to a complete finished running engine. And then we're going to have a pretty much, again, another all-star cast to have that round table to kind of go back through it. So over the next 3 days, we're going to begin to the engine block, work step by step with the leading manufacturers, best engine builders around the world, sharing their insights as we go through the how do you do it, not just talk about it conceptually, but we can actually, like you said, put it in the machine and run it. Make some chips. That's going to be cool, right? We're not just going to be running our mouths. We're going to make some chips and clean some stuff. We're going to torque some bolts and things while we're here, make it happen over the next 3 days. And then the great part is...
Well, exactly. What are we going to do with this? Like, we're going to have something at the end of this that we made the product of the Engine Performance Expo. What are we going to do with this?
We're going to give it away, of course, right?
Yeah.
Okay, so, you know, just like the shows, they would have a giveaway. All the watchers, the viewers, hang around. Someone is going to win the LSX short block, which again, Dart, Diamond, Liberty, there's a cast of thousands, right, that have helped produce this piece. Someone's going to win it. So,
Fantastic.
We want to encourage you to share and invite your friends, and you can copy and paste the link, and we expect the audience to build. We expect people to come in and out as they are able to. It is great, but listen, if you're trying to win the block, we still want you to share with your friends.
Yeah, I know.
Don't try to corner the market. That's not how it works. That's not how it works. And Andy, seeing the machines put through their paces, that's going to be so exciting to me.
Yeah, it'll be a fantastic thing. This is the way information gets spread around the world to learn over the internet like this. So, wonderful opportunity for everybody.
I just know for me personally that the process of gathering all of this information, because there is a whole team of people that have been running all over the country for the last 4 months, filming these things in these people's shops. Doing that process, have learned so much. I mean, it's been like transformational for somebody like myself that's grown up around racing my whole life. That's in the last 4 months, I've learned so much just gathering it. Again, we're hyping it up, but this is going to be transformational. The nuggets, the information that's going to come over these next 3 days, you're going to appreciate. Best free money you ever spent.
Well, exactly. The price is right. And just in my process out at the NHRA, and of course doing my podcast, I get to interact with a lot of engine builders and smart people. And I think we're seeing this transition, like a generational transition, and we're going to notice it. And the next generation must get involved in this information, like the use of technology, the use of computers. Andy was telling me about his grandfather's original innovations, on Model Ts and Model As for cylinders. And now to think that these machines, computers, computer screens, touch screens, can do all of these things, but there is a foundational education required, and that's what we're trying to do.
Extremely important, yes.
And that's probably the overarching view of this whole thing, is that a lot of our industry was based on analog technology. And there are some people here that were going to be those guys. Like, Warren's been a great example. A guy that started off doing things by the sound and the feel. Not the sound and feel still don't matter, but the reality in today's technology, we've got the digital technology that allows you to be more precise and more repeatable, and that's the key to success and performance.
Yeah. Understanding the old technology is very important, but we've got to progress and learn how to use the new technology to be more productive in the shop, or produce parts that are more accurate, that are going to make those cars go faster.
And that's the reason why there isn't just one good engine in your fleet of engines anymore, and they are all almost exactly the same down to the horsepower, because you're not doing it by ear or feel, you're doing it using the technology. All right, so we're about to get started with our first bit. How do we start out building an LS engine? We've got to figure out how to select the block.
Yep, got to begin with the block, and so Dart is going to help us understand how you make an engine block.
Today we're going to give you a little sneak peek into our state-of-the-art manufacturing facility and let you hear from a couple of our employees. For those of you that aren't familiar with Dart, we were founded by Richard Maskin back in 1981 in a two-car garage in Oak Park, Michigan. In the years since Maskin started Dart with a desk and a telephone, we've become the proven leader in aftermarket cylinder heads, intake manifolds, and engine blocks. So sit back and enjoy the tour. Dart Machinery's Technology Center and manufacturing facility have joined together into a new 82,000 square foot building located in Warren, Michigan. Our machining and qualifying is designed to maintain the highest level of quality throughout the manufacturing process. Our production runs 24 hours a day, 7 days a week. These top-of-the-line machines are the same ones used by major automotive manufacturers, as well as some of the aerospace industry. Each Dart component is thoroughly inspected to ensure that they are free of porosity and other defects. Dart is committed in producing the best engine components available. All development, machining, and assembly are done at our own facilities in order to maintain the highest standards of quality. State-of-the-art CNC machining centers and proprietary speed flow technology wet flow bench are among the assets that contribute to Dart's advantage.
My name's Gordon Hahn. I'm the manufacturing manager here at Dart. I've been here since I started with Dave in 1980, and started back then. We had a couple Bridgeports and a couple lathes. We grew that into boring mills, and teamed up with Richard and Dart in '95. And I'm responsible for programming all the machines, the process, engineering. Right now I'm standing in front of our Op1 machine. It does all the qualifying for all of our blocks. Everything starts out here. We qualify the blocks, machining the ends, and prep them for the datum points for Op2.
Dart makes use of highly advanced CNC technology for finished machining procedures and porting. Our 5-axis CNC machines craft blocks and heads with precision and detail.
My name's Joe Stoller. I'm the cylinder head production supervisor here at Dart Machinery. I've been here 2 years. I come from an engine builder background. I own my own shop for 15 years and worked at some high-end race engine shops here in the Detroit metro area. One thing I like working about at Dart is we get to work with several different types of cylinder heads, from Fords, Chevys, big blocks, LSs, and we're constantly trying to develop those heads to make things better for our customers and for the race engine builder. One of my favorite products here in the cylinder head department is our 20-degree big block Chevy head. It has super stable valve train, one-piece bar from either Jessel or T&D. It makes great power, great torque, and is very reliable for all of our customers.
Getting the best results requires the right tool for the job, so Dart employs an array of highly specialized machinery to optimize every process. Our Sun and SV20 CNC hone allows us to maintain extraordinary bore size accuracy and carefully control the peaks and valleys of the bore, achieving the perfect hone in a fraction of the time.
Hi, I'm Scott. I've been working here at DART for 35 years. I'm the block supervisor in charge of everything that goes through the block department. Why I think DART stands out is consistency and how accurate our blocks are compared to what's out there on the market. So everything's looking up. They keep on advancing the company. It's been great as far as sales. The company's still going strong, but it's great to have it here in the United States.
We use an advanced Zeiss coordinate measuring machine to ensure the utmost accuracy in each part produced. The Zeiss is capable of measuring hundreds of points along virtually any surface of a part.
My name's Matt Jeanette. I'm the head of the inventory control group here, so we do planning, purchasing, shipping, and receiving. I've been at DART since 1991, minus a small time where I went and worked with one of our customers, Jigs. So I worked at a time when the business started from the basement. We went to a building in Troy, and obviously we've grown into our new facility in Warren. So I was here during the years where Richard Maskin, our owner, was building pro stock engines for championship teams like Jim Yates and the Coughlin brothers, Jeggy in particular. So we don't just make the parts here, we've actually raced all of the parts, and those relationships still stay intact with all of our customers today. We don't just sell to warehouses and places like that. We actually work with all of the engine builders and make sure that our technology and the things that we're offering are still top of the line in the industry and the highest performance parts available. We've done things over the years that a lot of people haven't, especially with our billet line or our race type products, where we use different manufacturing techniques, different machining that no one else in the industry does, that separates our product and, you know, helps our customers move to the forefront of the racing industry. So whether it's at a racetrack or in the marine industry or even enthusiast hot rodder, we try and make sure that we're building a part that is the best available, the highest quality, and then the price is good, and also try and deliver it in an amount of time that meets everybody's needs. So.
Hi, I'm Mark Mickey. I'm the driver of Jason Carter's 78 Malibu. We currently run the car in Pro 275, but the history of the car, we won the inaugural Sweet 16. This car still holds the RVW mile-an-hour record, 221 miles an hour. It's a 78 Malibu. We utilize a big block Chevrolet, 540 cubic inches. Right now, like I said, we switched it over to the 275. Just a little bit fits the class a little bit, or the car fits the class a little better. We utilize some components, like we utilize a DART billet block. I think we've been using these for about 3 years. Really, the DART block changed our program around. It's a great product. The service, the durability of this thing is second to none. We beat the crap out of it. We run almost 90 pounds of boost in these motors. So just a testament of how good, solid foundation of the motor is.
There aren't any shortcuts when it comes to crafting the best performing, most reliable components around. At DART, we believe the formula is hard work, seasoned experience, and the best equipment money can buy.
Jeff Lake. I work here at DART Machinery, been going on 13 years now, here in the SHP department. It's where we do a lot of block preps for our customers, WDs, and we have our short block program that we assemble back here. We sell a lot of those to WDs. This is a brand new Little M that is fully prepped that's going to be a short block when it leaves here. And on our block prep, we finish the decks, and they're super smooth for an MLS gasket. The bores are finished, home to the torque plate. Freeze plugs are put in, oil galley plugs are put in. It's clean, it's ready to go. This is the same block that you would get if you were just buying a block prep and taking the block out of the box, and it's ready for you to assemble. The only difference is this one's on the stand and this one's going to be a short block. And by doing this, you know, we touch all these blocks, so it's another form of quality control for us because we're working on the finished product that we're machining.
Hey guys, my name is Mike Sanders. I'm Product Development Manager for Dart Machinery. I've been here for 20 years. Currently, I'm working on reviewing our new LS7 flow figures, which currently has 461.4 CFM and 900 lift. In the future, be on the lookout in 2021 for our new Iron Eagle small block Ford. The Iron Eagle is landed. I'm also reviewing our new Big Chief 3, the new exhaust port for nitrous applications.
Enjoyed the little peek into Dart Machinery. If you'd like more info, please give us a shout at 248-362-1188 or check us out on our website at dartheads.com. Thank you for 40 years of support and business. We appreciate you all. And remember, Dart heads and blocks win races.
Welcome back. Thanks to Dart for that great video talking about engine blocks. Joining me is my friend David Lewis and Jimmy Barton from Robert Yates Racing Engines, guys who actually use some Dart engine blocks in their NASCAR spec engine program. So one little note before we move on, a little housekeeping tidbit. If you're having problems with the audio, make sure your player is not muted. Now, in the top section there should be a button. You can make sure that you're not muted, and then turn the volume up if you're having problems hearing. So, that taken care of, let's get into Dart blocks, or in this case was the Dart LS Next block is the one that they've donated to the expo that we're going to be machining here and kind of moving through. Well, that's a block you guys have a little bit of familiarity with. Tell me a little bit about your backstory on how you came about using and choosing the Dart LS Next block.
We do a spec engine program for NASCAR, and they have it. We were using the LS2 block, 6 liter, and GM discontinued that block, so we had to go out and find a suitable replacement at a cost-effective price point.
Right. So I also know from my time back at Joe Gibbs Racing that at the beginning of that program, when we were using the factory block, that factory block had a couple of shortcomings when we were using it as a race engine, because obviously it wasn't designed as a race block, and putting it in a race car. What were some of the problems we saw there, Jimmy?
Well, the structural integrity of the block in a street car, it's mounted on rubber biscuits that mount it, and you tie it down in a race car and use it as a structural member. The car will twist it and crack it and stuff like that. And the RPM range in the motor was not really conducive for nearly 8,000 RPM with the crank, 6 counterweight crank in it. So that and the structurability of the car, where it uses a structure element, tend to crack the mains in.
I remember that at Gibbs. We had Joey Logano was driving for us back then, using those as he's a kid, right? Seeing the main webs crack for that very reason.
And it's usually number 2 and 4, and they crack right through the oil galley, and then it was potential to lose the rods in it because it lost oil pressure.
Correct.
But I mean, it was just an inherent GM designed engine that's made for a street car that you put in a race car.
And of course, we know there's lots of people that are running street LS, factory block engines
with great success.
Oh yeah, so it happens.
Horsepower.
Right, but there becomes a point. There's a limitation, be it application-wise,
right,
how you install the engine in the car, or just the total amount of power that you're making, where that factory block, you're just exceeding its limits. And
the GM Performance book rates that block at 450 horsepower. We're making well over 600 with it, and some of the street guys with turbos and stuff are making 1,000 with it. But I mean, it's just limited.
Right. So then you can go on to the beefier block, more material, stronger. But there's another part about this LS Next block that the three of us have very familiarity with compared to the factory block, and that's the oiling system. Now, tomorrow morning, the guys from Melling are going to be on here doing a little video talking about the LS oiling system, but specifically the problem that the three of us worked together on when I was driven on the oiling and the oil flow issue. Why don't you address that a little bit?
Well, to start with, the motor doesn't flow a lot of oil because it's an aluminum block, and you have to spit the mains up tight to get it to have the proper clearance when it's hot. So when it's cold, it doesn't have enough clearance in it. But when it's hot, because that's a 2 oil galley block, which means that it oils through the lifters first before it gets to the mains. Then you got 16 oil leaks at the lifters when they get big. So it's just an oil flow problem there. The Dart block is a 3 oil galley block, which is priority oiled to the mains first and then restricted to the lifters, so it doesn't have the problem that 2 oil galley block has.
I'm trying to remember the numbers exactly. When we were doing the testing with the oil flow with the baseline oil, what was the gallons per minute difference between the two blocks?
About 2 gallons.
About 2 gallons. That's significant. I remember the windage, higher RPM, obviously the oil pump's moving faster because it's in your case, you're using a dry sump system, but for the guys who are still using it with the factory wet sump system, higher the RPM of the engine, the more oil you're putting through it, windage becomes a big issue.
Well, in our application at 200 degrees with our clearances, the GM block had about 7, almost 8 gallons of oil flow a minute, and the Dart block was down in the mid-6s.
Wow.
And
so way better oil control.
Oil control, and it held the clearances a little better, just because of the steel caps and all.
Exactly. So those are some big advances and of why you would choose that type of block to upgrade your program to move forward, which of course Dart talked about. But other applications where your experience of building all kinds of engines well beyond just the NASCAR spec engines. Talk a little bit about application and how that's going to dictate what your block selection is going to be in terms of material and things like that.
Well, if you're going to use it as a structural part of the car, you need a better block with the better aluminum in it, like the Dart block, because it's stiffer. The GM block is not designed to be a structural component of the car. So, if you're going to get anything over probably 500-600 horsepower, you're pushing the limit of the GM block. This motor here, the Dart engine, should handle easily 1,000-1,500, no problem. And I've heard way greater than that on it, but personal experience is not there for it.
Exactly. So obviously there's aluminum blocks, there's iron blocks, and even within the iron block family, there's compacted graphite, which is just kind of its own little unique beast. Talk a little bit about, we were kind of preview for later in the day where we're going to you guys are going to come back and we're going to talk about piston to wall clearance and some pins and things. Talk about a sleeved block, wet sleeve versus a
cast-in sleeve?
Yes.
The GM block is a cast-in sleeve.
Okay.
So if something happens to that sleeve, you can't do anything with it but bore it out and bore the block, and you're taking material out of the block when you do. The Dart block comes with a 4300 bore in it, which means they put a sleeve in that block that's very thick, and the bore size can go all the way up to 4185. It's max they recommend. You can go a little further, but you know, you got a 300 thousandths thick block, and that's sleeve in that block versus you got about a 60 or 80 thousandths thick sleeve in the GM block.
So it gives you a lot more flexibility in terms of bore stroke combinations.
For bore stroke combination.
That's awesome.
And the repairability of the block itself.
Well, yeah, because now you know it's going to be able to live longer, more oversizes.
Well, you can change the sleeves in that block.
Oh, see, another big advantage.
Yeah.
So, all right. So the next video segment we're going to get to is going to go into Suma bore. So still going to hang out with aluminum blocks for a little bit, but we're going to bring in my buddy Jake Raby, who's a Porsche specialist. We're going to go from a V8 engine to a flat 6 engine. We're going to talk a little bit about bore coating and going to say Nikasil versus Alusil versus Suma bore, which is a new advanced coating, which you guys are a little bit familiar with as well, which requires a whole honing process as well. But we're going to go ahead and let Jake take it over and start talking about what happens when you choose to do a coated bore versus a sleeved engine, and what those considerations are and things to look for and where we're headed in the future. So we'll go ahead and let Jake take it away. Hi there, Lake Speed Jr. Total Seal Piston Rings, and I'm here in Cleveland, Georgia with my good buddy Jake Raby, home of Flat 6 Innovations, Raby Aircooled Technologies, and a host of other things. IMS Solutions was invented here, right here. So, and Jake and I have been doing testing together for well over a decade now. Yes. So, the reason why we're here today is to talk a little bit about one of my favorite topics, ring seal soup. And you're like, okay, what does that have to do with this Porsche block in front of me and these scuffed up pistons? Bear with us. Because ring seal and ring seal soup, that mixture, that coming together of the piston and the ring and the oil and the cylinder wall finish, which that's what this little thing is here for, is Mitutoyo profilometer that can measure that cylinder bore finish. All of those, just like any other good soup, be it Italian wedding soup or New England clam chowder, they all have to come together, but they are different. So, but one thing about these engines is pretty unique, and Jake's experience here is that, you know, a Nikasil cylinder is pretty much a Nikasil cylinder. Doesn't really matter if it's in a water-cooled motor or an air-cooled motor, because it's that surface material of the piston, skirt coating of the piston, the oil of the surface finish, all of that has to work together. And it really doesn't matter if it's water-cooled or air-cooled. Exactly. All that piston ring knows is it's running against this type of surface material, this type of surface finish, and oil is the same thing. So, Jake, tell them a little bit about what you've been up to here recently and why all this matters and relates to ring seal soup.
Well, first thing I'll say is until just a couple of years ago, or really this year, for the majority of engine builders and people, especially in the Porsche industry, ring seal soup was not on the menu, okay?
Yeah.
Because people are so stuck in doing the things they've always done. They get on cruise control, especially if you work with air-cooled engines that had the factory Nikasil cylinders. The stuff just works, right? You know, the 996 turbo, 997 turbo, GT3s that came factory with Nikasil cylinders, they don't have problems like we see with this M96 and M97 engine that had the Locasil cylinders from the factory. So the fact that ring seal soup is a new and upcoming thing for the menu on so many people's menus is a great thing. And even things like the profilometer have been just black art until the last year or so. Like, this is stuff that we just didn't see people doing. You know, there was no webinars about surface roughness. There was none of this stuff. We had to figure this out empirically. We had to see what worked and what didn't. We had to fail. We had to see what ring seal was doing. We had to see what lubrication was doing. And we just had to figure this stuff out. and it was a black art that's not quite so black anymore. And we're really working with Lake and the guys at Total Seal and Ellen Engineering and even Oak Ridge National Laboratories. We're working together for the semi-bore technology and working to apply that to both air-cooled and water-cooled Porsche engines. Now, what's very unique is I cut my teeth on air-cooled Porsche engines, and right here on this property, for many years, I never would allow a water-cooled Porsche to be here. And until I bought a Boxster, and I was told by Charles at Ellen Engineering, hey, we've got to get to the bottom of these things because these engines have major problems. I'm like, whoa, hold on a minute, problems? That's me. If it's a black sheep and it's a problem, I want to work on it. And to all you guys out there that are in the industry of working on engines and designing things for Chevys or Fords or whatever, that niche market is what you need to be looking at. What engine has a problem? I don't want to work on things that don't have a problem. I find it quite boring, right?
Yes. Oh yeah.
So realistically, with this, the number one problem, even though this engine has 31 modes of failure that I've documented on this property, everything from intermediate shaft bearings, timing chain failures, cylinder bore scoring, piston failures, of all of those,
all right here.
Number one, the very first problem that we attacked with this engine series and family was cylinder bore scoring. And even today, 15, 18 years later, we're continuing to learn things about this. I learned things about this 2 days ago I didn't know 3 days ago. So it's using tools like this, applying the semi-bore, changing piston skirt coatings, changing ring coatings, changing ring tensions. All of those things have been very, very unique in what they've added to that suit that you're talking
they're
about.
all the ingredients in that suit.
Absolutely. And you can make one change to those ingredients and see something radically different. Just last week, we changed something with the soup recipe, and we end up with a cylinder that looks horrible compared to a cylinder that looks perfect, and there was 4 pounds of ring tension difference. Same exact roughness average, same exact ring package. The only thing was I altered the oil ring tension on one cylinder by 4 pounds, and it changed everything. So this is all grassroots empirical data that we're learning from messing with this. And what I like about it is since I cut my teeth on air-cooled engines, I put together this air-cooled engine that's a mule for the dyno, and I can have a cylinder head off this engine in 17 minutes. And last week I had one off in 11 minutes because I was really wanting to get from some results, and I wanted to see what things were doing while the engine was still hot.
Right.
So I'm pulling the cylinder head off with welding gloves, right? So being able to take that simple engine that doesn't even have head gaskets and use it to develop technology for an engine that is many series of engine families beyond it and newer than it is, has been something that has really woke me up to a lot of this. And seeing what the surface finishes are doing is incredible.
Well, that's really cool about the air-cooled engine being able, because they are sleeves, jugs, right, that you can modularly interchange. It allows you to do some pretty unique stuff like run one coating on one side and a different coating on the other side. And we shouldn't say coating because Sumabore is actually a thermal spray coating that's applied inside the bore. But Nicosil is something completely different. Yes.
Plating. So, coating goes on low pressure, plating goes on high pressure. And, people ask me, well, why are you trying to get away from Nicosil? And I say, look, we are not trying to get away from Nicosil. We are afraid, and we know that Nicosil is trying to get away from us because of the environmentalists.
Well, they are chrome. It's an old school coating process that's chemical, just like Nicosil. It's chemical in nature, which means, as we both know, in the last 15 years, anybody should be knowing that the chemical regulations around the world have changed dramatically. There are not a lot of chemical compounds today that are blends of multiple chemicals that could be the exact same composition as they were 20 years ago, simply because environmental regulations have made some chemicals go away completely. Chlorinated paraffins, some of them have been eliminated. Some remain, some are eliminated. Some detergent additives and motor oil eliminated because of all these things. So, trying to stay ahead of the game, and you see it at the OE level.
Absolutely. That's where it started.
Those guys are all going from Nicosil, going to Sumabor. So you got to get your arms wrapped around Sumabor, because if Nicosil goes away because of environmental reasons, and the thing is, people are saying that with Sumabor, they're seeing lower tailpipe emissions, less oil consumption. Yeah. All things that are good for the environment are coming from Sumabor. So Sumabor is probably going to be a deal that's here to stay.
Exactly.
So we're working together to get on top of it, because, Sumabor is not new to the racing market. Been around for a long time. Formula One, things like that. NASCAR guys used it 10 years ago. Yes. Yeah, exactly. But the reality is that's a very different operating environment than what we're seeing in the street.
And I mean, we're bringing this stuff to the production world for performance engines, for guys that are in a niche market like we are with these Porsche engines. And, I don't really know of anybody that's working on it at the level that we have kind of worked on this at, as far as trying to get it perfected before we need to, because that's the idea. The Nicosil, we know, is probably going to go away. And if it doesn't go away, it's going to end up being so much more expensive, because there's over a dozen acids that are required to prep one of these blocks for the Nicosil process, because it is plating. Each one of those has an acid wash to neutralize it between different acid baths. So when you do that, you're creating thousands of gallons a year of hazardous material that you have to pay to dispose of.
Right.
So, a lot of the cost in plating these blocks isn't the actual cost related to doing the plating. It's the cost related to getting rid of all of those hazardous things. And people don't know that unless you've been doing this the way we have. So the idea is, I like to head things off. So does Charles at Ellen Engineering. And we saw the fact that these blocks were a perfect way to utilize Sumabor. And also the 9 Alpha 1, the newer, the 2009 and newer Porsche engines, which we are having a even more difficult and more expensive time doing the plating work to with Nicosil, because those blocks are an Alguacil material. So they have an even different process procedure to use the Nicosil plating, because they're Alguacil and not Loxacil like this. So the whole block changes.
Right.
So when you have something like this going on, and we're trying to beat the environment and beat things that we don't have any control over, it really starts to pull you away and take that focus away from the performance. Everybody's asking me, how much horsepower are you seeing? I don't even care.
Yeah, it doesn't matter.
We don't even care right now. Because what we do know is once you get the ingredients right to that recipe for the soup, once you get ring seal, once you're able to hold more cylinder pressure, once you're able to cut down the tailpipe emissions, once you're able to keep the oil cleaner in the engine because you have ring seal, you are going to make more power than you will any other way.
Right.
Because you've got to have that. The ring seal is what creates the compression that is the lifeblood of the combustion. So if we get good ring seal, we will make more power with the Sumabor than we've ever been able to make with Nicosil.
With more durability.
With more durability and with less impact on the environment. And we're going to beat everybody to the punch in our market because nobody else is doing this.
Right.
And we're already, 2 years ahead of them with what we're doing now.
Oh, yeah.
This has been in the works for 2 years. So we're used to people copying us, right? It happens all the time.
Oh, yeah.
When you're out front, when you're the lead dog, it's what
do.
happens.
Hey, that's why I'm in Cleveland, Georgia, because we're great development partners. But as Charles and his staff coming in, Jake and all of our team together, Keith, Kevin, all the guys back at Total Seal, we put all this effort collectively because we're smarter together than we are separate, and we can get these things done. So one interesting thing about this block, that bore material, and Sumabor we were discussing earlier before we went on camera here, is the fact that, Alguacil and Loxacil, it's silicon nodules inside the material that are being exposed. So it's like the honing process is exposing these peaks. Whereas Sumabor is kind of the opposite. Why don't you elaborate on that? So stay with us because this is the most interesting part of this whole thing and pretty insightful of why those pistons look the way they do.
Absolutely. So to set the stage a little bit, we already said that the first failure we ever saw with these engines was cylinder bore scoring, right? And they had some other cylinder sleeve problems in the early engines. But this engine has been really really just handicapped by that problem. And it went that way all through the manufacturing days. And it's even stayed that way in the aftermarket world of trying to build these engines. Right. People are trying to use steel sleeves and do all kinds of things because they don't want to spend the money on putting a proper aluminum sleeve in there and then doing a nickel plating process to it. So what we're trying to figure out, not just make Superbore work, right? But always we're trying to figure out what is the underlying stuff that makes the soup that makes these cylinders fail with these engines. So what I'm already seeing as I take the profilometer and I measure cylinders that have failed in blocks, and we measure them at different places in the block, we see already that a lot of the numbers we're seeing from the Locacil, either above ring travel or below ring travel, or even parts of the cylinder that has never seen a piston load or a ring load, is the cylinders that have failed have greatly huge changes in the RVK, RPK, RK, all those things, all the different surface finish values.
I'm going to hold that up there. Maybe I'll see it, may not be able to see it. But in this case, you have a higher RPK, which is the peak height. The area sticking up above the mean center line is greater than the RVK, which is the valley depth. Which basically means you have more peaks going up, contacting the piston, and basically breaking through the lubrication film, versus the valley that we holding that oil. Exactly. So that was measured, like you said, below ring travel, where it's virgin material. Yes, that's what it would have seen after that. Now, when we actually measure that same cylinder at a different location, we saw a different result. And that's because it saw a different kind of load during the time that it operated. So what I've noticed is a lot of these blocks only have one cylinder is bad. One cylinder stored, the other ones are fine. Every block that I've measured to date that had a stored cylinder, if I measured it virgin, the RPK numbers would be much higher than all the other cylinders, which proves that that surface finish from the factory had a lot of tiny peaks all over it. Those peaks are unit loading, basically. You have that. So once that happens, then you start having wear occur not just to the piston skirt, but the piston rings and all the things that are in the soup. And once it gets hurt and you have those things start, then now your piston skirt coating starts to fail. You're lacing your engine oil with fuel because now you don't have fuel control. We're not keeping that in there. Goes up. And we notice that these engines that have the bore scoring go on have extremely black oil. It looks like a diesel. You can run the engine for 1,000 miles on the engine oil, and it comes out black. Okay? That's one of the big symptoms of cylinder bore scoring if you don't have the other symptoms yet, because you were lacing that oil with the hydrocarbons much earlier than any other symptom shows up. Right. So, another reason why you should be doing used oil analysis, by the way, because it will show that up. You can see that increased fuel dilution. You can see that silicon going up. Again, if you use just your generic labs, they're going to tell you that silicon is dirt and you need to change your air filter. Yeah. Not in one of these motors. But if they watch our videos on RenVision, where we talked about the used oil analysis and what we find with bore scoring, then that used oil analysis company might change how they respond in their summary at the bottom. Because after we released that video, within 2 weeks, a very popular company out there they kind of changed their tune from, well, you got silicon in your oil, so you need to change your air filter. It went from, you know what? You got silicon in your oil, your aluminum's higher, your fuel intrusion's higher, and this is a Porsche M96 engine. You might have bore scoring. This is no joke. It happened. It happened last year. Okay? So that's what happens. But that's one reason we share this, right? That's okay. They learned about that. Well, it helps somebody else. They give us some credit for that. That'd be nice. We did their homework for them. Oh, yeah. But they don't build engines, that's the thing. Exactly. So, but if you do good used oil analysis, and if you change the oil frequently enough, yes, you're able to determine those things. You can see it. And that means not your annual oil service interval, at least do it twice a year. So what we're getting at is the cylinders in these engines that seem to have the
the best chance of bore scoring are having the highest peaks in their surface finish. And that's not where the piston or piston rings have been riding. This is an area of the bore that is virgin, that has never had any radial load or anything like that placed on it while the engine is running. Now, we also were able to get a brand new DFI Porsche block, a 9 Alpha 1, for a 2014 911. And that particular car, we measured that bore, and we noticed some very unique things about that from a brand new block from the factory. So we'll share that later on, but that was a brand new virgin crankcase, never been ran, never been assembled, and we've learned a lot from that one. And we learned a lot from going from one cylinder to the next, and even measuring different places in the cylinder, which that's where Brad's tool comes in, holder for the stylus. That is the best thing ever. It's a very simple tool, that he just had the idea to come up with it, and it allows us to measure these blocks at different locations, different axes, all that sort of thing. But this engine is a great one to work with to solve this problem, because the cars are still very valuable in the minds of the owners that want to keep the car for a long time. The cars are great.
Oh, they're great cars.
Yeah, they're tanks. The car's a tank, but the engine has got so many problems. And, I believe that the Locasil the factory used with these engines was an early effort to try Sumabore. They wanted the result that Sumabore is able to give, but they did it with such a huge budget cut. And you got to face it, this is developed in the 90s. Okay?
Right.
So I don't really know the first time Sumabore was used. We need to research that.
You should.
But I think from the way that this works and the idea behind it, it was a kind of a economic answer to what Sumabore is.
But they were going away from platings because they could see the future coming and say, Nicosil is not going to be our future. We need to give it to a different bore material that can do the things we wanted to do, like Sumabore can do. But this one just didn't work out that well. And again, a lot of it comes back to the fact that you are, like we said, you're taking these silicon nodules and you're honing it to try to expose those nodules. But the problem is if you have too much of a peak, now it breaks your lubricating film and increases wear because it's a very hard cutting tool and can do that kind of damage where that's what the skirt coating is supposed to look like. That's what it looked like when it scores, where Sumabore doesn't have those nodules. It's thermally sprayed, then diamond honed to a mirror finish.
Exactly.
It's the porosity. It's like a sponge that holds it. So it's like the opposite. So as opposed to having these peaks sticking up, it's got all these little valleys and pores down that hold that oil.
It looks horrible. I mean, if you look at it, and you look at it real closely, it looks like it's already worn. That's the thing about it. And if you look at it on a perfectly good M96 block, that's Locasil like this one, and it hasn't scored, it looks the same way. It has that same kind of look to a naked eye, but the profilometer says something completely different.
Yeah.
So that it proves that there's two ways to skin the cat, as we say. See the cat back there, right?
Oh, exactly.
There's two ways to skin the cat. But, it's one of those things where as we learn about this and as we're able to see what works and doesn't work, it starts to puzzle my mind even more, because all these engines that may have horrible looking pistons and horrible looking cylinders come out of them, the rings are never hurt. That ring, which I would like to look at some of them underneath the total seal microscope. Maybe you need to take these back with you. But if you look at them and you take a pick or something and run over them, you can't feel any voids in these rings. It's almost like they made another kind of error by choosing the rings that were being used against these cylinders.
Well, you see, you brought up a good point here. That's one of the other things that has changed in the last 10, 15 years, is that piston ring manufacturers the world over have moved away from the traditional, ductile iron, moly-faced ring. Well, that moly-faced ring had a lot of porosity and could hold a lot of oil and would make up for some deficiencies in bore finish. But when you're going to higher compression engines, you're going to these harder materials, you got to go away from that soft moly. Now we're into steel rings, PVD coated rings, gas nitrided rings. Well, those steel rings can handle tremendous amounts of heat, especially turbocharged. Can handle the heat, handle the boost, handle very hard materials. Downside is they don't hold any oil.
Yeah.
So now that surface finish becomes more critical. You know, this whole thing reminds me so much of the whole zinc and flat tappet cam thing from 15 years ago, that it was this kind of confluence of multiple things that came together to create that issue. And I kind of see this ring seal soup as this same thing that's recurring, that
absolutely
it's the change in bore materials, the change in fuels, change in ring materials are all coming together to make surface finish, which is why if you're talking surface finish and you don't own one of these, you really don't know what you're talking about.
Yeah, I mean, you don't know what you don't know. Like I said, 5 years ago, who was talking about this? Most people did not even know that these tools existed.
Right.
And still today, even though it's become a very hot topic, how many machine shops we were just talking about? Yeah, I run a 360, 400 home through it. It's good. It's a plateau finish. It's good. That's what you've been doing. But everything's changing. And like we said, what I'm learning now is that especially with Sumibor, we are going to find out that we are going to have yet another requirement for a different flavor of brake-in oil. We're already seeing it.
Yeah.
And I'm running a test next week. While everybody else is off for Christmas, I'm running a test next week that proves, hopefully, something that I'm thinking about that doesn't make a lot of sense even to you. But I'm doing it because of what I've seen and because I have to rule it out. Okay?
Right.
And that's from an oil perspective. Now, you talk about ring tension. We've already seen a crazy difference in what Locasil and Nicosil and Sumibor need for ring tension. It's crazy. And it's not what people had told us it would be.
Yeah, it's not the logical
That's right.
process. Which is in your test next week, is you're going a direction opposite of what conventional wisdom is,
Yes.
but you're following the trail that what your experience is saying, hey, something doesn't add up here. I need to verify it.
And the thing is, when I do this work, guys, I don't sit around and read stuff about it. This engine is my teacher. I have to pay attention to it. I have to give it the variables.
Yep.
I have to listen to it. And it is telling me what it needs in its own language. And you have to be able to listen to that. So too many times people overthink this stuff.
Right.
And you overthink it to the point, and you think about how it's supposed to work, you miss the point completely.
Oh, exactly. It's telling you a story. You just got to be willing to slow down and listen to it and then believe it.
Absolutely. And it doesn't matter if it makes sense to anybody else. Because at the end of the day, when this thing speaks the language I want to hear, I know that I'm going to use that to spank everybody else out there. And they need to learn this just like we did.
Oh, yeah. And they will. I've already proved it, right?
It takes time.
Yeah. So, anyway, I hope y'all enjoyed that. We appreciate you tuning in. Stay tuned for more information on Sumibor testing from Jake and Lake.
Thank you.
Bye.
CEO and founder of Blueprint Engines. I wanted to take a moment to thank the folks that are putting on the first ever Engine Performance Expo. When I heard about this expo, I got really excited. Like a lot of you, we haven't been to very many trade shows lately. So I wanted to help. I reached out to Rottler and to Chris Straub to see how easy it was to help, and they said, it's really easy, you just write a check. Hi, good morning. I'm Norris Marshall, President, CEO, and founder of Blueprint Engines. I wanted to take a moment to thank the folks that are putting on the first ever Engine Performance Expo. When I heard about this expo, I got really excited. Like a lot of you, we haven't been to very many trade shows lately. So I wanted to help. I reached out to Rottler and to Chris Straub to see how easy it was to help, and they said, it's really easy, you just write a check. So we wrote them a check and became a sponsor. Then they said, you need a 5-minute video. So we pieced together a video. It's got a few stories in it and some video clips of the plant. I think you'll enjoy it. But mostly, I want to thank Chris Straub, Straub Technologies, Andy Rottler, Rottler Manufacturing, Randy Neal, CWT Technologies, and Lake Speed Jr. with Total Seal for helping to bring this together and put this on, plus all the other sponsors and presenters, and especially you for being here for this expo. Enjoy the show. Thank you. Started out as a young man, as a kid. My dad was into racing. My dad grew up in the 50s, had the flat top, had the 32 Ford Roadster, flathead V8. Later went on to drag race and do some circle track racing. By the time I came along, all that was over, but I heard all those stories. So I was always interested and enthused about the performance market. I did some dirt track racing, some drag racing, and I knew I didn't want to work on cars. I wanted to work on engines, and performance engines are a lot more fun than stock engines. So Blueprint Engines really started a long time ago in 1982 and really started hitting its stride in the last 10 years. The thing that makes Blueprint Engines fantastic is the people here. I'm so proud of the people that I get to work with. I've been in business for 38 years, and we have lots of great ideas, and we have lots of good equipment and lots of wonderful things in the plant, but the people are what makes it great. Blueprint Engines truly is a family. Matter of fact, a lot of the people that I work with here I like better than some of the members of my family, and they'd probably say the same thing. We're very lucky that we get to work together, and we welcome new members of the family whenever it's right.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.